So properties of logs, as stated, difficult section. There are really three different properties of logs that you're going to deal with. Okay, so there's three different properties of logs, and these are properties that work hand in hand with exponential properties. And I'm actually going to write the exponential property with it, okay, so that you can kind of understand what's going on. But the properties of logs will start out with something called the product property. So the product property of a log, and these are all going to be general. So we'll go through more specific stuff in a second, but these are all very, very general. If you have a log with a certain base, it doesn't matter what that base is. And then you have two things on the inside of a log being multiplied together, so m times n. So if you have two base or a log with one base with two things multiplying inside, then you can split this up and you can call it log base b of m plus log base b of n. Now, if you remember, this works very, very closely with the exponential powers, because in the exponential powers, the product property for exponents is a to the m times a to the n is equal to a to the m plus n. So it's kind of the same idea. See how it's kind of the same idea? Where you're taking a log and you have two things being multiplied, so you take the log and now you have two things being added. Okay? But it's a little bit backwards. So you know how I said it's kind of like the inverse of it? In this one, you're starting out with one log on the left side, and it breaks up into two logs with an addition sign. On this one, you have one base with an addition sign, and two bases with a multiplication sign. So it's kind of like two bases and addition, where it's two bases and multiplication. So it's the opposite. It's kind of flipped a little bit. Okay? So that's how these things are related to the exponential powers. And you can kind of see how it's, I guess you can kind of see how it should be related to each other pretty clearly. The next one is the quotient property. Now, most of you should be able to figure out what the quotient property is at least going to have in it. It's going to have division in it first off. And if it has division, when you think of dividing exponents, what do you do with the exponents? You subtract. So you already know the property that has to do with the log. So most of you could probably finish this before you even need to start. So you could say log base b of m divided by n is equal to log base b of m minus log base b of n. So log base b of m divided by n is equal to log base b of m minus log base b of n. Now again, this is very similar to the product property with, or the quotient property with exponents. So if I had something like a to the m divided by a to the n, that's equal to a to the m minus n. Same kind of idea that we just talked about. But again, if you know these properties and you understand what's going on with these properties, it shouldn't be too bad when you get into the log aspect of things. The properties themselves should not be the end of the world. The thing that is going to be the end of the world, if you have trouble with them, is condensing and expanding. That's what we're going to spend most of the time on today. All right, the last one is called the power property. So if I have the power property, it means if I have log base b of m to the n power. Now, when you have a power raised to a power, what do? You multiply. Same thing is going to happen here. You multiply, but this number out front comes up front, or up top comes up front. So n times log base b of n. But again, power to a power, which is kind of what that thing looks like, you multiply. So now we have, if we're looking at the exponential form, there's multiplication happening here with the power to a power. Same kind of thing is happening with the log. Make sense as we sit here right now? Now, wait, what's the other? You good? So, big concept that I want you to understand. The actual properties themselves aren't going to be too bad. The actual condensing and expanding isn't going to be too bad, as long as you follow the appropriate amount of steps. As long as you go through and find out what you should do first, as long as you're careful with parentheses, as long as you're careful, this isn't that bad. But if you don't have a clue what's going on, it's going to be pretty terrible trying to condense and expand these things, because trying to follow an order that you don't understand is very tough. Okay? It really is just a set where you have to go through step by step by step, and as long as you followed all the steps you're supposed to, it's not too bad. Just make sure you understand those steps. So the first thing I want to define here is condensing and expanding logs. So these are directions that you are going to see in your homework, in your quizzes, in your tests. You're going to see things that say condense the log and expand the log. So those are things that you're going to see. Condensing means to make smaller. So it is going to be to take a big log expression and make it smaller. And here I'm going to put ideally 1 log. So ideally, you're going to start with a whole bunch of logs, and you are going to condense it to 1. Okay? That's ideally what will happen. You will take a whole bunch of things, and you will condense it to just be 1 log. Expanding is the exact opposite. You are taking all of these things, you're taking a small thing and expanding it to as many logs as possible. So this is taking 1 log and you're trying to make as many log expressions as possible. Questions that you can see here, issues that you can see here, things that might make or might be confusing to you at all. Okay, so let's work through a couple examples. I'm going to show you how they work, and then I'm going to give you some time to try some on your own. Okay. So they start out to be a little bit easier, just with numbers, just with expressions, because sometimes it's easier to find numbers and expressions and see what they look like before we get into the actual algebra behind it. So let's say we have something like log base 2 of 7 over 3. So if I have something like log base 2 of 7 over 3, you can simplify this down and you can start to solve. Okay? So you can take this idea and you can start to solve it as you work your way through. I haven't taught you how to use your calculator yet. I'm probably going to teach you that today or show you that today, because there really isn't there is absolutely no reason that you should break this down and solve it by your calculator, other than the fact that I'm trying to show you what it looks like. Okay? I would never ever ask you to break this down. I would expect you to solve it in your calculator exactly like this. Okay? So when you're solving this, you're going to end up saying log base 2 of 7 minus log base 2 of 3. Now, I wouldn't ask you to simplify this any further as of right now, because we don't know how to use our calculator. And I think we're actually going to save that. We're going to save that till Monday. Some of you have found that there is a change of base formula in your calculator. If you hit the math button and start scrolling down a whole bunch, you can find that there's a change of base formula for your log in there. But we're not going to talk about it yet. It's not super important yet. Okay. So the questions that are a little bit more challenging are things like this. If I see something that says expand ln of 5x squared over y. So if I see something that looks like this, obviously there's nothing I can do to solve this. There's 2 variables. It's not even really an expression. It's just asking me to expand it to make it bigger. Now, there are times in equations that we're going to be dealing with in the next couple of sections where it makes way more sense to have this in an expanded out form than it does in a condensed form. This is what condensed looks like. Your answer when you're done with condensed should look like this. All right? So when you're condensed, this is what it should look like. When you're expanding, it should have a whole bunch of things there. So we're going the opposite. We're expanding this thing. We're making as many log functions as possible. Okay? So now, the way that you do this is you deal with order of operations of the actual thing inside of the parentheses. Okay? So you can see in the parentheses that if I were to solve all of these with real numbers, if I were to solve, how do I want to say this? So what you want to do is you want to try to undo or move things as you would when you're solving an equation. That's the best way to think about it. You want to undo these things as if you're solving an equation. So the first thing that you would do is you would get rid of the y if you were solving this equation, right? You would move the y out of the denominator to try to start solving this. You take care of the division first. So that's what you're going to take care of with your properties first. This stuff right here can't happen until the division happens. So we're getting the division out. Then we're going to break everything else down as we move on. So the first thing I'm going to do in this problem is the quotient property. So as I break down the quotient property, it's going to be ln of 5x squared over y is equal to ln of 5x squared minus ln of y. Now you're going to notice that when I do these, I overuse parentheses a lot. Your book sometimes doesn't use the parentheses as much as I use the parentheses, and that's fine. I just don't want to confuse myself with my work about how many parentheses to use and so on and so forth. Okay, so I undid the division first. Now I just try to break down as much as I can. This thing right here, I can't do anything to. It's already by itself. There's no properties that can work when something is by itself. Okay? So there's no property here that I can do. This one has properties, right? But as I'm solving this equation, the first thing that I would take care of is this 5, not the squared part, right? So if you think about it as solving the equation, I want to undo this thing right here, that 5. So if I undo that 5, that means I'm going to use the product property. I'm going to get that out of there, okay? So I'm going to use the product property, which means that this thing right here will turn into ln of 5 plus ln of x squared minus ln of y. So you see how I just broke down that multiplication? So I'm just working backwards as I go through these. I'm trying to work backwards. And then finally, the last thing I do is I look through to see if there are any other spots, if there's anything else that can be broken down. Because I've already got all of the multiplication out. I've got all of the division out. The last thing I have to do is check to see if there are any powers, which obviously there's a power here. So the power property just means I take that 2 and I move it out front, in front of that log, not in front of everything else. So power property, it would end up equaling ln of 5 plus 2 times ln of x minus ln of y. Okay, so I'm going to walk through the process again. Yeah, Sean.
So when we expand, we don't write them as powers because they were initially powers.
Correct. Yep. Yep. So when you're expanding, you want no powers, you want no multiplication, and you want no division. You want none of those 3 things at all. Okay. No powers, no division, no multiplication. Typically, the order of expanding things goes quotient, product, power. Typically, that's what happens. Okay. Typically, the order of the way that you do things when you're expanding goes quotient, product, power. Now, I'm not going to say that happens every single time, but I would bet most times that's the order that I try things. Quotient, then product, then power. Those are the 3 ways that you're going to do this. I'm going to give you guys one and see if you can do it. After we get done with that, we'll go through an expanding one, and we should be okay. Or a condensing one, and we should be good. So let's say that we've got, Yes, this is expanding again. Do I want to make this a tough one? I'm going to make this a tough one so you can see what it looks like. Yeah, you're welcome. Well, you're going to be happier that I do this in the notes than on a quiz.
Yeah. Oh, that's very important. No one necessarily understands. Oh, no.
So again, remember when I said overuse your parentheses. Use parentheses because in this case, and I'm going to tell you in a second, negatives become an issue. So overuse your parentheses, but everything about this should be pretty much the same. So how many things am I dividing by? 2. How many things should I be subtracting then? 2, right? I'm dividing by 2 things, which means that I should have 2 subtraction signs. Because that's what would happen if I was dealing with exponents, right? If I was dividing by 2 things, I would subtract twice. Same thing's happening with logs. If I'm dividing by 2 things, I'm going to subtract twice. So this is where I said be careful with your parentheses. So we start out with quotient first. I'm dividing by this entire thing down here, yz. So I'm going to do log base 6 of 3x to the 4th minus this entire thing log base 6 of yz. Now this is where you're going to lose your negative. This is what's going to happen. We are dividing by this entire thing right here, right? I'm going to put a set of parentheses right here because I'm dividing by that entire thing. That's where that issue is going to come into play. Because at the very end, and I'll show you what the answer looks like that a lot of you probably had, which would technically be different because addition is commutative, your answer would be different than my answer. So let's keep working. Now I've gotten rid of my quotient, which means that the next thing I'm going to do is the product rule. I can do all of the product rules at the same time. Some of you are going to get to the point where you can just start skipping steps. Like you realize that this 4 would end up coming out front, so you can just start doing all those steps. I don't care. I don't have an issue with that. But it's something that you have to get comfortable with before you start skipping steps. So my next step is the product property. So log base 6 of 3 plus, oops, I don't want that. Plus log base 6 of x to the 4th minus, and I'm going to put this whole thing in parentheses right here, log base 6 of y plus log base 6 of z. So all I did was the product property in each of those things, right? I had a plus sign in between these, plus sign in between these, plus sign in between these, plus sign in between these. Yeah.
So wait, why are we doing that?
Because we're dividing by this whole thing right here. So since there's more than one thing here, I'm going to put a set of parentheses here. If you want to be careful, like in this problem right here, I could have put a set of parentheses right here if I wanted to, but throughout the entire course of the problem, nothing else shows up. So if you want to be really careful, you can put parentheses anytime that you divide by something. And then at the end, just pay attention to it. But in this one, I'm dividing by more than one thing. So I put the parentheses there because I'm dividing by 2 things. If I don't put the parentheses there, one of them is going to turn into a positive. Yeah.
So you don't care if we just subtract them by each other?
Not at all. Nope. If that's a step you want to take from the very beginning, that's totally fine. It's just not a step that a lot of people see right away. Okay. So then the last one, I go through and I check to see if there are any powers, which there are. So there's no powers in the first one, so it's going to be log base 6 of 3. This one does have a power, so it's going to be plus 4 log base 6 of x. This one doesn't have a power, but now if you notice, I can just distribute the negative through here. So I'm going to say minus log base 6 of y. And then the negative is going to get distributed through here, so it's going to be log base 6 of z. Now again, why I said that most of you would probably get a 4 out of 5 is because what I bet most people had was they got this right, they got this right, they got this right, and they had a plus sign here. That's what I would bet. Yeah, go ahead.
This might have just been what Sean just asked, but like right at the beginning, since there's a y and a z that's not there, can you just like immediately split those up and do like minus log base 6 y minus?
Absolutely. Yep. I don't care what steps you guys take, as long as you get to the final answer. There's like 5 or 6 different ways to get from the start of this to the end of this. I don't care what direction you take. It doesn't matter to me. I'm showing you the bare bones. This is what I would teach to every single person so that they can do this with every single problem from the very beginning of time. And it would work for every single one of your questions. Every single one. If you want to skip steps, that's fine, but make sure that you don't forget. Okay? I want to show you, I want you to try one problem over the weekend or whatever to see if you can understand what's going on and see if you can go the other way with it. So let's say that we have log base 3 of x plus log base 3 of, let's say 2 log base 3 of 4 minus log base 3 of y. So I want you to try to condense that. That's what we haven't really talked about yet. But I'm hoping that if you understand the expanding part, or the expanding part, you can figure out the condensing part because it's the opposite. So instead of doing quotient power or quotient product power, now you're going to flip them. You're going to do power product quotient. Okay. So if you have questions on this, let me know. We'll work through it together. We'll get back to it on Monday, and we should be able to finish it up.